Our first question that we're going to take a look at, find the equation of the line in slope-intercept form that goes through the points -3, 2, and 6, -1. So I'm going to encourage you that even if you don't know how to do this whole problem, see if you can at least think how to do part of it is better than nothing, okay? Hopefully we remember how to do all of it, but even if you only remember how to do some of it, do what you know. Okay, I'm going to have you pause for a second just to make sure you're on the right track. Did you remember that the first thing you should be doing is finding the slope of the line, okay? And just in case you forgot how to do that, this is the formula y2 minus y1 over x2 minus x1. And then, you know, x comes first in an order pair, then y. And then we have 0.1, 0.2. Okay, so if you didn't find the slope yet, that's what you need to be doing right now. And then try to keep going from there. Okay, remember we're trying to write an equation and we need it to be in slope-intercept form. So go ahead and keep working. All right, so our slope we should have done -1 minus 2 over 6 minus -3. That'd be like 6 plus 3. So it's -3. You need to actually divide it by 9. You're going to get a repeating decimal if you do that. -0.3 repeating. So you need to math frac it. We're going to leave it as -1/3. Now, guys, I'm going to draw like a dividing line here because there's two different ways you could proceed from here. If we think about all the ways to write a linear equation, yes, it wants us to do it in slope-intercept form, but we don't know B. We don't know the y-intercept. Like if we make a graph, this point is not on the y-axis and neither is this point. So it's also reasonable to start in point slope form. You just can't leave your answer in point slope form. I'm guessing most of you probably did it this way, so I'm going to go over that way first. Remember, you just have to pick a point on the line when you're using point slope form. It can be any point. So if I want to use this point, I'd write y minus 2 equals my slope times the quantity of x minus -3. So we need to make that x plus 3. And then we just can't leave it like that because it wants it in slope-intercept form. Like our final answer needs to look like this. So we got to get rid of the parentheses. We got to distribute -1/3 times x. -1/3 times 3 is -1. And then we got to add 2 to both sides to finish it. So we'd have -1/3 x, and then -1 plus 2 is a +1. Okay. Again, I think most of you probably did it that way. But there is another way you can do it. You don't have to use point slope form. We could use slope intercept form and use that same point and fill in the 2 where the y is, fill in our slope for m, and the -3 where the x is, and then b will be the only thing missing. We could solve it for b then, since we don't know b. We'd have to multiply these together to get 1. And then to solve for b, you'd have to get rid of this 1. 2 minus 1 is 1. So if you do it that way, now that you know what b is, you're ready to write your equation because you could fill in the b value that you just found. And then we know that m we found was -1/3. So notice we got the same thing that we got right here. You can do it either way. It's two methods to do the same problem. Guys, a good way to check your work, if you're taking the final exam and you finish and you have a little time left to spare, a great way to check your work on this question is you could go plug this in y equals on your fancy calculator and go look at the table. And both of these points here had better be in the table, because if they're not, you did something wrong, because the line is supposed to contain both of those points. Okay. All right, moving on to the next one. Tell whether the lines are parallel, perpendicular, or neither. I'm going to give you, again, a minute to think about this, but you're going to have to be thinking, what makes lines parallel to each other in the coordinate plane? Like, we know parallel means that they never intersect each other, okay? But, like, what makes that happen in the coordinate plane? And we know that perpendicular means they cross each other at a right angle. But, again, what makes that happen in the coordinate plane? I'll just give you one reminder that it's something about their slopes. So, in other words, we need to be thinking about what's the slope of this line and what's the slope of this line. Okay, that's all I'm going to say. You take a minute or two and get started on this one. So again, guys, this problem is all about slope. In case you forgot, you might want to add this to your notes. Parallel lines have to have the same slope, and perpendicular lines have to have slopes that are opposite reciprocals. We'll review what that means in a second, but again, I'd probably add it to your notes if you didn't remember that. So again, because the line on the left is already in slope-intercept form, it's easy for us to know the slope. All we have to do is look for m. So the slope is 4 in that one. This one's in standard form, right? Remember standard form? Standard form doesn't have an m in it. So we can't see the slope when it's in standard form. We have to get y alone first so that we'll be in slope-intercept form. So we need to take away 8x from both sides. When we do that, we're going to have a negative 2y left on this side. Don't forget, guys, that 14 and 8x are not like terms. We can't physically combine them, so we just have to write 14 minus 8x, or we could flip it around and put the negative 8x first and then the positive 14. That's what I would do, just so that it's in this order, right? Because eventually we're going to look for what m is. But we have to have y alone. Y is still not alone. Maybe put your dot in here to remind yourself it means negative 2 times y. We got to do the opposite and divide everything by negative 2, right? So you got to do negative 8 divided by negative 2 to get 4. And then also 14 divided by negative 2 to get negative 7. Let's go ahead and compare the slopes. We said the slope of this one is 4. The slope of this one is also 4. So at first glance, it looks like they're parallel. Landon? Yeah, why? Yeah, we have to be careful, guys, because they also have the same y-intercept of negative 7. So if we graphed it, it would look like the first line, and then the second line would be right on top of it. They're the same line, so they're not parallel. Parallel, they'd have to have a different y-intercept. Like this line would be parallel to the one I just drew. See how they don't have the same y-intercept? They would have the same slope, though, the same rise over run, okay? But because they're the same line, we can't say parallel or perpendicular, so we would say neither. I do want to remind you guys of a vocabulary word. You might not remember because it's been a while since we talked about it, but when the lines are the exact same like that, one line on top of the other, there is a word for that. It's called coincident. You're not going to need to know that on your final exam, okay? I'm not going to be that evil on your final exam. I won't give you one where the y-intercepts are the same. I'll purposely make those different, okay, so that you only have to look at the slope to make it a little bit easier for you, okay? We're going to practice one more slide of knowing whether the lines are parallel, perpendicular, or neither one. This one is a little bit easier because if you look through, all the equations already have y alone. So we're already, like, we can know the slope already just by looking, since they're all in slope-intercept form already, right? We just need to look at the m in every question. So you go through real quick and take a minute here to decide each pair, like on A, would those be parallel, perpendicular, or neither? And then what about B? We should be able to do it in just about a minute because we don't really have to do any math because it's already in slope-intercept form. All right, let's look at the first pair of lines. The slope of this one is 2/3, so is the slope of this one. And they don't have the same y-intercept. So if we graphed it, we would see something like this. And guys, you know, you always could graph it in your graphing calculator, right? Like we could just go plug this in y1 and this in y2 and go look at the picture, and that's what you would see. You would see two parallel lines. Okay, the next one, we have -3, but then +3. So we definitely don't want to say parallel because they have to be the same number to be parallel. Now, those are opposite, okay, but to be perpendicular, they have to be opposite and reciprocal. These are not reciprocal because let's make this look like a fraction for a second. The reciprocal of that and opposite would be positive 1 over 3. But this doesn't say that. It says 3 over 1. It's not flipped over. That's what reciprocal means, remember? So because they're only opposite, not reciprocal, then these would be neither. Like they're not going to be parallel and they're also not going to be perpendicular. If you graphed it, it would look something like this. Like they're going to cross at some point, but the point that they cross at, let me try to do a little better. I can't do it. I'm terrible at drawing. The angle they cross at is not going to be a right angle, okay? They're not perpendicular. So we have to say neither for that one. Okay, I was really trying to drive home the fact here that to be perpendicular, they have to be opposite and reciprocal, okay? Do you notice on C, they're reciprocals this time? This is what we mean. Reciprocal means flipped over. See, the first one has 5 in the numerator, but the second one has it in the denominator, and then the 8, so the 5 and the 8 are flipped. But they can't be perpendicular if they're both negative, right? Think about it for a second, guys. If you graph two lines, if they're both going down, the angle that they cross at is not going to be, well, that was terrible again. If they're both going down, I was trying to say, the angle they cross at's not going to be a right angle is the point, okay? One would have to be going up and the other down for it to be a right angle. That's why they have to be opposite and reciprocal. These ones are reciprocal, but they're not opposite, okay? The last example is finally one where they would be perpendicular, because this time the slopes are opposite, like this one's negative and this one's positive, but they're also reciprocals. This one's 3 over 7, this one's 7 over 3. So one more time, it has to be both in order to be perpendicular, okay? I hope that kind of just like clears that up a little bit, because I feel like back in this chapter, we had a little bit of trouble knowing whether things were perpendicular or parallel. So do we have any questions about that example at all? All right, let's do a review of writing the equation of a line. So in order to write the equation of a line, we need to know the slope and the y-intercept. Then we would be able to use this formula. Okay, so I'm going to kind of set it up like this. We're going to fill in the blanks here. Okay, so let's look for the y-intercept first. So where does it cross the y-axis? Right here at -3. So instead of plus -3, we can actually just put -3. Okay. Now let's talk about slope. Slope, remember the catchphrase, rise over run? So you have to count from one point on the line to another. So we need another point on the line besides -3, the y-intercept. Let's just go ahead and use this one. It looks nice. So guys, when you count your rise over run though, your rise is down 3. It needs to be -3 and then right 1, 2, 3, 4. So -3 over 4. I saw a couple of you with +3 over 4. Guys, let's utilize our graphing calculator. If I think the answer is y equals 3/4 x minus 3, I could go graph that and look what it looks like. Not what the picture on the board looked like, because that line's going up and this one's going down. So that should help you remember, oh yeah, I need a negative slope here. So let's go back and insert a negative here. And now look at that. It matches the picture on the board, okay? So we don't want to forget that when the line is going downward, we need a negative slope. All right, that's our final answer for that one. All right, we want to tell the slope and the y-intercept for this one. Go ahead and see if you remember how to do that. So hopefully you remember, again, from all the formulas that we've learned this year, that this is the equation of a line in standard form. So you can't tell the slope in the y-intercept unless it's in slope-intercept form, right? That's why it's called slope-intercept form, because you can tell the slope and y-intercept when it's in that form, okay? In other words, we need to get y alone. So we need to take away 9x on both sides. So carry down that equal sign. 9 minus 9 is 0. We would have just the negative 4y left. 12 minus 9x we would write, or we can put the negative 9x first, then the positive 12. We need to make sure opposite of multiplication that we divide everything by negative 4. So we have to do negative 9 divided by negative 4, which is going to be positive, and it's a decimal. We need a math bracket. So 9/4 x. 12 divided by negative 4 is negative 3. So now I can look at m to find my slope, 9/4. Remember we talked about yesterday, don't put x. Slope is the number in front of the x. It's the m, okay? And then b is our y-intercept, and that's negative 3. All right, we have a story problem next. Go ahead and read through that carefully and try this one. All right, so we have a home security company charging new customers $155 for installation. So that's, you would just pay that one time. That's a one-time fee. But then there's a monthly fee of $40. So like every time a month goes by, you have to pay another $40. If another month goes by, you have to pay another $40, right? Guys, a strategy I taught you just last week is we could take the number of months and figure out the cost. Like if no time has gone by, like you're just having them come out and set it up, you have to pay $155, right? But after 1 month goes by, you have to add 40 to that, right? So now it would cost $195. If another month goes by, you'd add another 40, so you'd be up to $235, right? You're repeatedly adding 40 over and over. Remember how when we practiced the difference between linear equations versus exponential equations, I told you that linear, you're adding the same amount over and over. That's what slope means, okay? If you were multiplying by the same amount, then it would be an exponential equation. So you could actually, if you made a table, you could even plug this in the stat button in your calculator and do linear regression if you really wanted to. But we shouldn't really need to do that because we should hopefully understand that the 40 is our slope since we're adding another $40 each month, right? Like if we fill in 2 here, if 2 months has gone by, you'd have to do 2 times 40, right? If 7 months goes by, you'd pay $40 7 times, right? And then no matter what, you have to add with that setup fee. You have to pay that whether you're going to use the company for 1 month or 100 months, right? You still have to pay the setup fee in the beginning, okay? Now, guys, we're so used to using y and x. Did you notice it wants us to use other variables, m for the number of months and c for the cost? So like right here is supposed to be an m, right? Because once again, if only 1 month goes by, you just pay $40 plus your setup fee. If 7 months goes by, 7 times 40 plus 155 is how you would find out the cost, right? We're using C for cost. So how would I now find out how much it's going to cost to use this company for a year? Maria? Right, because remember how it's $40 every month and a year is 12 months, right? So what we have to do is plug in 12 where m is. So we'd be doing 40 times 12 because you have to pay it 40 every month. That's $480 plus don't forget the setup fee, $155. It would cost a total of $635 for the whole year. Okay, any questions on that one at all? All right, we're going to do one more equation writing one from a story problem. So you go ahead and read through this one and try to write your equation. Don't worry about this part yet, okay? Just try to come up with the equation for me right now. All right, so we're buying 2 types of ribbon. The organza ribbon costs 7 cents per yard. So like the more yards you buy, the more you have to pay, right? 1 yard by itself would be 7 cents. If you buy 2 yards, you do 2 times 7 cents, right? And so on. Satin ribbon is 4 cents per yard. And it says that we want to know how much ribbon we can buy for $5. That's going to be important. So did anyone realize that what we should be doing is writing a standard form equation this time? Okay, so the last one was slope-intercept form because we were given the slope. We don't really have a number here this time that would represent the slope, but we do know the total amount we want to spend is $5. Whenever you know what the total is supposed to equal, oftentimes that should be a hint to that it's going to be a standard form equation, okay? So we have to have two variables because we're buying two different types of ribbon, right? Let's just go ahead and use X for organza ribbon and Y for satin ribbon. But each yard of organza costs 7 cents, right? So we want 0.07 times however many we buy, whether we buy 5 yards or 12 yards or 15 yards, we would do that number times 0.07. And then since we're using Y for satin ribbon and each yard costs 4 cents, we would put 0.04 times Y, however many yards that we buy, okay? That would be our equation. If we want to list set, now there's different combinations you could have, right? Like maybe you can buy 10 yards of organza ribbon. You would then have to figure out, after I buy that, like how much money is left to buy the satin ribbon. Or maybe you only want to buy 5 yards of organza ribbon. Then you want to figure out how much money will you still have left to buy the satin if you want it to add up to 5 every time. The easiest way, guys, to find all those different combinations is to solve for Y, because then you can just go plug it in your calculator and just look at the table and it will give you all kinds of different combinations, okay? We're actually not going to take the time to do that because we ran out of time in the other classes, and I would rather, we've already done a couple today where you have to get Y alone. So I would rather go on and review the exponent rules now, okay? So this was just a couple weeks ago that we did this. See if you remember how to simplify this expression using your exponent rules. All right, when we raise a power to power, we multiply them. 2 times 6 is 12. We have to remember there's a power here too, though. So like -3 to the 1 times 6. Guys, when you punch this in your calculator, -3 to the power of 6, remember you have to actually put the parentheses. So it should be positive 729 times y to the 12th power. Okay. See if you remember what to do with the next one. Don't forget that our final answer cannot have negative exponents in it. Okay, once again, guys, I'd probably write this as 2 to the 1st power, because we have to remember that this exponent has to apply to every exponent in here. This, again, is where we multiply the exponents. 1 times -3 is -3. 4 times -3 is -12. I would not press this into your calculator. You're going to get a decimal if you do that, and we don't want to just math frac it. Instead, we need to be remembering how to use our negative exponent rule. So negative exponent rule has to do with reciprocals or flipping fractions. So let's first of all make this look like a fraction, because then remember what we do? We flip it so we can make it 2 to the positive 3rd and b to the positive 12th. And then we can punch it in our calculator. Now that it's 2 to the positive 3rd, that's just 8. And then b to the 12th. So this fraction is our answer. How many of you got that right? Good. All right, one more exponent rule one. Go ahead and try this one. Okay, the 21 divided by 7 part, like those are just normal numbers. We just want to do 21 divided by 7. That's 3, or 3 over 1 if you really wanted to put the 1 there, okay? X to the 8th divided by x to the 5th. Did we remember that this is the rule where we subtract the exponents? So 8 minus 5 is 3. Remember, it goes in the numerator, okay? X to the power of 3. Even when you do 2 minus 10, even though it's -8, I still want you to write it in the numerator for right now. And 4 minus 9 is -5. Then we'll use that negative exponent rule. So this part should stay where it is, right? We're going to move this part to the denominator so we can make it y to the positive 8 times z to the positive 5th. We don't really need times 1 anymore. We don't need that 1 because 1 times y to the 8th is just y to the 8th. Questions on that one at all? All right, we just had a quiz on this a couple days ago, but go ahead and see if you remember it. So you deposit $700 in a savings account that earns 6% annual interest compounded yearly. You don't make any other deposits or withdrawals. Write a function that models the balance in the account over time. So guys, a lot of the questions we did today were review about linear equations. This one is exponential. How do I know that? Because when you want to find the percent of a number, remember how of means multiply, and exponential equations are what we use when you multiply by the same thing over and over and over, because that would be your b value, okay? So our a value, remember, is the starting amount. It'd be the y-intercept if we made a graph. The b value, remember guys, you're not going to straight up use this number. You have to either add that number to 100% first or take it away from 100%, depending on whether this is a situation where something is growing or decreasing. And compound interest is a growth problem. Like, you're going to have more money next year than you have right now, and then even more the next year. To be exact, if you take 100% plus 6% to get 106%, each year you're going to have 106% of whatever you had the year before. Because, right, if you just do 100% of 700, it would stay 700 all the time. It's supposed to be growing. So we need this number, if we change it to a decimal, we need it to be more than 1, right? Some of you just put 0.06. That would make it go down. Like, the graph would look like this. It would be decay. It's supposed to be growing. We need it to be over 100%. So then if we want to know how much money we're going to have after 4 years, we just fill in 4 here. So you would go to your calculator and do 700 times 1.06 raised to the power of 4. And you should get $883.73. All right, last one. I told you there's going to be one equation solving problem on your exam. Let me tell you, it is going to look just like this. So if you did not get p equals -1, try and look for your mistake here. So first thing we should do is distribute. 4 times 2p is 8p. 4 times -3 is -12. We have p's on both sides. We need to get them all into one side. I would take them away from the right side so that you just have -12 left on this side. 16p minus 8p is 8p. Guys, hold on for 1 second. Get your constants on the other side, so add 4 to both sides so you can cancel it on the left. -12 plus 4 is -8. So to get p alone, opposite of multiplication, we are doing -8 divided by 8, -1.